Hello, this is the third part of the chapter 2.1, and we will talk today about the properties of matrix multiplication. So you might notice that the matrix multiplication is quite different of the other operations, mathematical operations you studied so far. It has some properties similar to operation on normal numbers, but some are dramatically different. So we have to be very, very careful operating with the matrices. And there is like 5 basic laws which help us to work with the matrices and work with matrix manipulations. For example, the one big laws which we will use all the time in this course is called associative law of matrix multiplication. So when we are multiplying 3 matrices, we can either multiply the first 2 by the third one, or we can multiply first by product of 2 others. So we basically can use a different order of multiplication, and we will still get the same matrix at the end. Okay, so another very useful law is the left distributive laws. For example, when we apply matrix A by the sum of other 2 matrices, B and C, we can basically distribute our matrix A. We multiply matrix A by B, we multiply matrix A by C, and then we add them together. And we also can reverse the order of matrix and the sum here and write things down as a right distributive law. So when we have a sum of 2 matrices multiplied by the third matrix, we can distribute matrix R from the right, as we call it. So we multiply matrix B by A, matrix C by A, and add them together. Another useful law is a scalar multiplication. So when we have a product of 2 matrices, A and B, and we multiply it by the scalar or parameter or number R, we can easily multiply this R either on A, either on B, and then carry on with the matrix multiplication. Finally, very, very important property, which we will use extensively for the rest of the course, is a representation as our matrix as the product of matrix and identity matrix. For example, if we have a matrix A, we can write it down, and our matrix A has a m by n size. We can write it down as the identity matrix size m by matrix A, or we can write it down as matrix A times n time identity matrix. And again, you notice that n and m is different because matrix M has a different numbers of row and columns. So if we're multiplying from the left, we need the m size matrix, and when from the right, we need the n size matrix to match the row and the columns in our original matrix A. Okay, but let's just try to carry out simple multiplication and see how it works. So we have matrix A here and matrix B, and we multiply A by B and B by A. You know, if we would deal with the 2 normal numbers, we would get the same result. Not so far in matrices. Okay, let's take matrix A and matrix B, and here we will conduct row by column multiplications of matrices. So basically, to find the value at the position 1, 1 at our product matrix AB, we take the first element of the first row on matrix A and multiply it by the first element of in the first column of matrix B, and then we take the second element of first row of matrix A and multiply it by the second element of the first column of matrix B. So it's row and column multiplication. Okay, and we will continue with every single position. For the position 1, 2, we will take the first row, second column. For the position 2, 1 over here, we take second row, first column. And finally, for position 2, 2, we take second row, second column. And again, that will take a practice. So you probably will work through 5, 7 examples and you will feel very comfortable with matrix multiplication. Okay, and when we count all our numbers, we get this nice matrix. So now let's go the other way. Let's go, takes matrix B and multiply it by A. And again, first row, first column, first row, second column, second row, first column, second row, second column. And the resulting matrix is, you probably noticed that it's quite different from the product A to B. So, and it's not the error of calculation. Indeed, in matrices, we cannot shift the order of multiplication. Matrices which results in product of A to B is not the same as product of B to A. It's because the linear combination involved, and it is a little bit more complicated, the simple number product. So there is several warnings which comes attached to the matrices. Matrices are awesome to calculate, but they are not following the same rules of mathematics you experienced so far. So we need to remember that in general, we cannot switch order of matrix in the multiplication. And sadly enough, all of you will make mistakes. Don't worry, just try to practice more and check all of your calculations. It's very common mistake on the test 1 when you just shift order of matrices. Okay, the second warning is that we actually cannot get the identity in the matrix laws. For example, when we are multiply matrix A by B and get the same matrix as the multiplication of matrix A by C, we cannot conclude that our matrix B and C is equal. For numbers, that's work. For matrix, doesn't work. And you can see exercise 10 to run through the derivation of this property. Okay, finally, if we have a product of two matrices equals 0, we cannot conclude that either one of the matrices involved is equal to 0. So if our AB equals 0, it doesn't mean that either A or B is equal 0. Sorry, that doesn't work. And again, you can derive this property, and it's listed in the exercise 12. Okay, so now go to the exercise and try to practice using the matrix law, but be very, very careful about properties which you cannot assume in when you're working with matrices. Okay, and I see in the final part of this chapter.